Good afternoon. My name is Welcome. I am a rising ninth grader at Burlington High School.
And I'm Finn. I'm a rising senior at Hanover High School in New Hampshire. So today we will be presenting on our proposed virtual outreach tool of a interactive soil model. Okay, so this project stems from three main factors. One, the lack of public knowledge we learned about in this academy toward the important functioning of Earth's soils. Two, the value of visual tools, especially in scientific education. And three, the capabilities of our modern day technology, both agriculturally and educationally. Um, as our professor reinforced to us, Eric, um, civilizations are dependent upon agriculture, and in the same way, agriculture is dependent upon healthy soils. Um, and so, therefore, we believe that the increase of public knowledge about soil health and the life in soils is vital to the future of our global society and ecosystem. This thing functions as a customizable infographic, basically, using layers that can be added to the simple background shown. Um, it also provides external resources in the Learn More section based upon your combination of layers chosen. Today we'll be showcasing three examples of how this tool could be used to educate the layperson on um, on topics we learned about on soils and sustainable agrotechnology. One of the lessons we hope that users can gain from this is the quote like innovation, that is the optimization of soil microbes and microbial diversity in soils. More recently, been doing this through inoculation, which definition above introducing a community into the soils. Microbes are most simply microscopic organisms. They can be found in soils, among other places. Most soil microbes are either fungi, bacteria, archaea, and in the in the food web, they are important because they digest substances that other organisms cannot, um, along with having the capability to reach further into the soil than roots can. As it says, this is not to scale, they are microscopic, um, and therefore they often form symbiotic relationships with roots, so these nutrients can be obtained. Um, and just a fun fact I'd like to share is that in 1 teaspoon of soil, it's estimated they're estimated to be more microbes than people on Earth. So sustaining these microbes and protecting them is important, as chemical usage, as we most commonly use, degrades this. So just like the world above the soil, diversity, the biodiversity is very important in the soil, and we believe that we as humans need to help this, and we hope this tool can be educational in that.
A strong example, a strong example of the beneficial interactions of soil microorganisms and plant root systems is during the nitrogen cycle, where nitrogen fixing plants form symbiotic relationships with a bacteria called rhizobia. The nitrogen cycle is crucial for maintaining a productive and healthy ecosystem and is a very important nutrient for plants. However, not all forms of nitrogen are usable by plants. For example, atmospheric nitrogen, and this is where nitrogen fixing plants come in. Um, Nitrogen fixing plants are legumes such as alfalfa, clovers, green beans, soybeans, and etc. These these nitrogen fixing plants have nodules in their roots that house bacteria, again called rhizobia, that fix nitrogen into ammonia, a fertilizer that is a different form of nitrogen. that can be used by plants. Nitrogen can also be fixed through industrial processes that create synthetic fertilizer. This form of fixing occurs under high heat and pressure, during which atmospheric nitrogen and hydrogen combine to make ammonia. And this uses large amounts of fossil fuels. This relates back to what Finn was saying earlier about using the natural systems of nutrient uptake rather than their polluting chemical counterparts. Because nitrogen fixing plants increase the amount of nutrients in the soil, it can be useful to intercrop legumes with other plants. And this brings us back to a study on Carranza, a perennial grain that we are intercropping with nitrogen fixers. So Carranza have root systems that can grow up to 12 feet long, allowing them to store carbon deep in the soil. And this also allows them to increase carbon sequestration and protect soil from erosion through their deep root systems that also take hold of the soil and keep it from wearing away.
I'd like to share this quote that our professor used a more modern usage, but an old quote, but we believe does a great job summarizing why our tool could be important, why soil education important. So we know more about the movement of celestial bodies above than we do of the soil underfoot. And yeah, we'd like to all these people and organizations for helping us so much, getting us here, and sources.
Thank you. There was a lot of a wealth of information in that presentation on soil, and just incredibly informative. And I'm curious for both of you, what was the most interesting or surprising thing you learned about soil when you were doing your research and learning over the course of Agritech?
Well, I thought it was interesting to learn all of the life in the soil, as our tool shows that you can't really see that cross section very frequently. It's just under, and it's under these layers, and there's just so much life in it. And I think we just got a nice introduction by our professor. And I didn't know all the life you learn about earthworms when you're young and stuff, but all the microbes, and it's described as living often in the sources that we used, and that was very surprising to me, as you think it is an inanimate object, just dirt,
I agree, and something else that amazed me was how everything is really affected by the health of the soil.
It's okay. That's okay. It's tired.
Great. Thank you, Finn, and welcome. Great teamwork. That's really good. It's hard to move the mic back and forth. And we clearly have some Renaissance students here. Making those connections, really important. And thanking your professor. I love that, and the team. Fabulous. Thanks so much.